dear students and participants on this course of railway engineering. I welcome you all back to the lectures. We are continuing our journey on the railway engineering, and today we are going to talk further on sleepers. In the previous lecture, we started with sleepers and we discussed about the various functions which the sleepers provide as a part of a track, and then what are the requirements which the sleeper should have so that it provides the complete adequate strength and the stiffness whatever is required along with the elasticity to the track. Towards the end we talked about the sleeper density and then the sleeper spacing, and we found that in some of the cases this can also be correlated, and it also depends on what are the loads which are coming on the track and what are the rail sections which have been used along with what is the supporting system which has been provided at the bottom. Today we will extend this discussion and we will be talking about the various types of sleepers. If we start looking back, we will found that there used to be wooden sleepers, and then came the steel trough sleepers and the cast iron sleepers, and now today what we have is a concrete sleeper. Now these wooden, steel trough sleepers and cast iron sleepers are slowly being replaced by the concrete sleepers all along the tracks across the length and width of the country. So our focus is going to be more on concrete sleepers, but we will also try to look at the various salient features which have been there, or the merits and demerits which have been there of the three above or the top sleepers which have been written here, that is wooden, cast iron and steel trough sleepers. There is a possibility at certain locations like girder bridges or points and crossings, a combination of sleepers needs to be used, and in that case that can be defined as a composite sleeper. Now let us start with wooden sleepers. Now wooden sleepers, there are two types, and that depends on whether those sleepers have been treated or they have not been treated. If the wooden sleepers have been treated or there is a requirement of a treatment, then they are usually non-durable type as being given here. But if there is a durable type, then there is no requirement of going for any treatment in that particular case. And the difference which comes is in terms of the service life. The durable sleepers, they have a higher service life as 19 years or around, whereas in the case of non-durable type the service life will be lesser, around 12 years, and they are being marked as U and T respectively. Now if you look at the merits of using the wooden sleepers, what we found is they used to be easy to manufacture and handle. So you need to have a log of the wood and then you cut it in pieces as per the requirements, that whatever is the width, height and length of the sleeper which is required, and that is done. Similarly, it was easier to handle these type of sleepers, and because it is a wood, it was observed that if you are going from a track circuiting, then in that particular case if track circuiting is being done, these are the best. Another thing is, from the inherent properties of the material, they had good elasticity and they had the good dampening effect. So this is another important aspect related to a track, because the loads are going to be there, the deflections are going to be there because of the loads, but the track has to come back. So it has to have a resilient condition that it sustains the loads and returns back to its original situation or a condition. But there used to be a number of problems which have been faced with the wooden sleepers. As we have seen that they have either a life of 12 years or 19 years. So this is termed as a short service life, because this life we are trying to look at in comparison to the other components which are being used in the track, and specifically here we are talking about the fastenings and the rails above the sleeper. So, if the life of the rails is higher and the life of the wooden sleeper is lower, then in that particular case what happens is you have to replace the sleepers at a faster rate at a shorter durations as compared to the rail. So, again and again you need to go for a renewal of a track. Another issue is that they are prone to mechanical wear or ant attack or any such type of a defect. Now, these sleepers, they have been provided at the top. So, if we look at any of the sleeper, and at the top of that we have provided the rail. So, a rail has been provided top of this sleeper, as you can see. So, in this case what will happen, that this rail seat, as the load comes here, that pressure comes here, that it is being exerted through the base. We are talking about a flat footed rail here. It starts putting the pressure below, and because of the type of relative softness of this material, which is a wood, it has been observed that more wear takes place in this base area. So, this is again a problem. Gauge maintenance also becomes difficult in this case. Now, if these type of things happens, now this widening of the gauge may starts happening, and then if you have to maintain it, you have to bring it back. So, you have to put the packings here, and again if the same thing happens, then you have to go for a maintenance of the gauge, and that is going to be a problem. In that sense, it happens is that the maintenance becomes a costly affair. Another issue is the creep. Though we have not discussed about the creep so far, we will be talking about it a bit later, but this is a longitudinal movement of the rails. So, if we talk about this rail section which is provided like this, then if the fastenings which are provided so as to sustain here these rails with the sleeper, if those fastenings goes loose, then what will happen? Along with the movement of the trains, there is a possibility that these rails will also start moving a bit, and that is a big problem here in the case of wooden sleepers. Scrap value is very low if you have to take out the sleepers at the renewal point and you want to get some money out of it. It is a very low value which comes here. And at the same time, now when you are facing the problems in terms of the overall environment, the green pastures and the green covers in the country as well as in the world, availability of timber is another issue. And looking at that aspect, it was decided then we should have different other types of sleepers also of either metal or concrete and so on, so that these type of sleepers can be replaced, and there is no further requirement of the timber in the case of the rail tracks. Now, in the case of wooden sleepers, one index is being usually talked, which is defined as composite sleeper index. This composite sleeper index actually tries to give you a value on the basis of its strength, and that strength is going to be in terms of a generalized strength with respect to the load taking capacity as well as the hardness. So, we have the load taking capacity being defined by S and the hardness as being defined by H. So, this CSI or a composite sleeper index, this becomes equals to the strength plus 10 times of the hardness, and this whole is being divided by 20, and this is done at a moisture content of 12%. So, seasoning of the wood has to be done. If there is a moisture in it, that has to be reduced. It should also not be too dry. So, the treatment is there, and on the basis of that treatment, once we have ensured that there is a 12% of the moisture content in the wooden sleeper, then we go for the strength testing and the hardness testing, and then we will get the values of S and H and we will put it there and in this equation, and we will get the value. Now, the minimum CSI values for the Indian Railways, they have been defined with respect to where this particular sleeper has been used. It can be a track sleeper. When we say track sleeper, it means we are talking about a normal track. In that case, the value can be 783. But if it is being used as a crossing, then it increases to almost double value, that is 1352. And if these sleepers are being used on the bridges, then further more strength is required. So, CSI value has to be further more higher. So, these are the various values which are there, and on the basis of the testings we have to identify whether the sleeper, the wooden sleeper specifically when we are talking here, can be used at that location or not. Now, another category is the steel trough sleeper. Now, these steel trough sleepers, as you can see in the photograph on the right hand side, this is a metal sheet. So, this metal sheet has been rolled in this form. So, it is a 13 mm thick if we are talking about a 52 kg per meter rail section or 90 R rail section. So, if this is these are the two rail sections, then it is defined as 13 mm thick, and if, accordingly if we are going for other rail sections, then the thickness has to be varied. And then another thing which is done, as you can see the shape. Here it is going straight, but then there is a curved portion at the ends. And these curved portions at the ends, actually if you have a ballast being provided at the bottom here, then this sleeper is getting inserted into that ballast cushion, and that is how the grip is going to be between the sleeper and the ballast. And at the rail seat here at this particular point where the rail is being seated, a cant is provided as 1 in 20, and this cant is required because we talked about the coning of wheels, and in that we found that the wheels have been coned. So, it was like this if you remember. So, this 1 in 20 was the slope which was given here with respect to the horizontal. So, that is a value which is being taken here. So, 1 in 20 if we have provided a slope or a cant to the seat, then the rail gets bit tilted, and now it will have a better contact area with the wheels. And the ends these are flattened to retain ballast, and the total weight of this particular sleeper is going to be 79 kg. But again, as I said, depending on the conditions, the type of rail sections or the sheet thickness which is being used, this value is going to be different. And this one which we are talking is for a broad gauge track. So, at the bottom also it is being shown that you have a cant of 1 in 20 here as well as 1 in 20 on this side. The rail has got tilted, and the gauge of if it is a broad gauge, so 1676 mm is being provided here as a clear distance between the two rails. There are certain fastenings with the help of which this rail is being attached to the steel trough sleeper, and then finally this end shape helps it to get into the ballast. Even it is and the inside also it is in such manner that it will retain the ballast inside. Now, when we are putting this rail at the top of these sleepers, there can be two ways in which the rail can be fit in. The one can be the pressed up lugs, and another is the with loose jaws. So, here we can see this is a pressed up lug condition. So, rail is being seated in the rail seat, there is a grooving being provided, and at that grooving there is one key which has been inserted, and that is how now the grip is going to be between the rail and the sleeper. In another case, what we have is we have a loose jaw which is provided and along with the key. So, as soon as the key is being inserted here, now this gets fixed and the rail will not move here in this space. So, you can see in the photograph which has been given on the right hand side. So, you have a steel trough sleeper at the bottom, and then this type of a fastening is being provided. So, a loose jaw is being created here and then it sticks there. So, the load has to be applied in that form so that the rail remains in position. So, what were the improvements when we started using the steel trough sleepers as compared to the wooden sleepers? The very first thing was the longer life. It had 30 to 40 years of the life as compared to 12 to 19 years in the case of wooden sleepers. It also provided the better lateral rigidity to the track system, and which was a problem in the case of a wooden sleeper. It was getting loosening, the gauge problem was also there, it needs to be maintained again and again. Then in the case of wood, there was a problem of ant decays, there was a problem or a possibility of a fire hazard. So, in this case it got free from any such type of a issue. And it was observed that if it has been taken out of after the life, or even if some irregularities has come into these steel trough sleepers, and if you go to the market, then the good scrap value was available for these type of sleepers as compared to the wooden sleepers. There was lesser damage during handling and transportation to these. So, this was also an added advantage here, and it posed less maintenance problems. Therefore, the maintenance cost was also getting down, and it also worked as an anti-creep sleeper. There was a problem of creep in the wooden sleepers because of the loosening. Now, here in this case it was working better, and rather we can say it was a good anti-creeper. Then another thing was it has hold gauge firmly, which was better than the wooden, as well as which was better than the cast iron sleepers, which just we are going to talk about. And the tolerance in this particular case was in a range of plus 2 mm and minus 1.5 mm. They were sturdy to withstand the beta packing. They were good on the yielding formations also. So, if the formation has a problem, you have provided a ballast cushion, and then if some undulations comes, still it was able to sustain such things, and it offered the longitudinal, lateral and the frame resistance. This was again a requirement of any component which is being used in the track. So, these were the improvements which were there, but there were some issues which still were observed. The very first thing was, on the basis of the material which is being used here, it was liable to corrosion. Obviously, this corrosion condition is going to be there, and it is very specific to the location, or it is very specific with respect to the meteorological conditions. So, if the chemical effects are there, if the moisture effects are there, the humid conditions are there, then the liability of towards the corrosion is going to be increased. Another issue was because the metal is being used, it was creating a problem with respect to the track circuiting. Therefore, some insulation has to be done wherever the track circuiting is being done. So, that was an added thing which came up on the use of these type of sleepers. Another issue was that it was becoming center bound due to the sloping ends. So, as we have seen in the diagram, this has a sloping ends condition. So, it was getting center bound. So, everything was coming towards the center. They also were really specific. If you are talking of 52 kg per meter, talking of 60 kg per meter, if you are talking of 90R rail, it means a different type of steel trough sleeper needs to be manufactured, transported and laid. It was developing cracks at the rail seat, as we have seen that we have provided a grooving there, we have set the rail there, and then we have inserted keys or the loose jaws so that the rail remains in position. But then because that crack, that space has been created within the shape and size of the sleeper, that became a portion where the cracks were getting developing. And fastenings were getting loose under the high frequency vibrations. So, that means if the speeds are very high, then in that case the vibrations are going to be there and the loosening of the fastenings will be there. And there was a problem with respect to the packing, and there was a problem with respect to the knocking at the joints, because there is unsupported area which is there. So, this unsupported area was creating a knocking sound. So, that was another thing. Then another category of sleepers which were there have been used were cast iron sleepers. Now, one of the thing which we are looking here is a cast iron pot sleeper. You can see the shape. So, it is a just an inverted pot which is being used, it is hollow inside, and then it is being provided with a tie bar. So, this is a tie bar. So, this is going like this, so otherwise it is hollow, and then at the top again the space has been created where the rail can be seated, and then it has to be capped in location by use of keys and clips. So, more or less the similar condition is there as we have talked in the case of a steel trough sleeper, but it has been observed that this particular sleeper is not suitable for curves which are sharper than 4 degrees, and fittings are hidden, and therefore maintenance was difficult because it is going inside. As you can see in this area, it is inside. So, if anything wrong happens to this particular fitting inside of this CI pot sleeper, then it is not visible, you cannot identify, and there is a problem which is going to be there in future which is not being foreseen. The advantage of this type of system was another, that if even though the tie bar is passing through it, the ballast which is being laid, that ballast will also go inside, and again this will provide you a better interlocking of the sleeper with the ballast cushion. So, that is one side of an advantage also of the shape of this, and in that sense if you see that there is a one pot being provided here. So, there is going to be another pot on the other side, and on the top of that will be a rail which will be fixed here. So, this is how it will look like. Then there was another development by the Indian Railways, it is being termed as CST 9. CST 9 is Central Standard Trial number 9. So, this Central Standard Trial number 9 actually was one of the most successful of the trials, even though after that also some numbers have come, some trials have come with being given as numbers like 11 and so, but this was the most used sleeper in that category. It was a combination of pot, plate and box. So, you can see here the shapes which are being shown. So, triangular inverted pots were there with a central plate with projected keel and box on top of the plate. Actually, this projected keel provides further strengthening in terms of getting inside and providing a better connectivity and a cohesion with respect to the rest of the components, specifically ballast. And it reduced the rocking of the sleeper under the rail wave motion. So, this rail wave motion means that if the rail is being provided in this direction like this, and the wheel is moving at the top of it with a certain speed v, then there will be a depression here in this form. And if this rail keeps moving, so you will find that wherever this wheel comes, the depressions will come in this form. So, or there is the connectivity, it will go in this way. So, there is a wave motion which is get created. So, that was another thing. Now, bearing area of the standard wooden sleeper, what was there in that case in the CST 9 also, it was designed in such a manner that the similar bearing area was available, and that means there was a better transfer of loads from the rails to the ballast cushion. And uses, if we talk, then it is a long through tie bar is there, a small canted rail seat is there, it has all of these components, two-way keys which arrest the creep, and the central keel for anchorage, as I said. So, these are some of the components which have been used along with the sleeper. Then it was easy to transport and assemble. It had high longitudinal and lateral resistance. It was considered to be a sturdy sleeper, and the depth at the rail seat was equivalent to wooden sleeper. It was roughly around 140 mm, and the service life was also good. It was 35 to 50 years. So, more or less equivalent to as we discussed previously for the steel trough sleeper also. So, here you can see that how these CST sleepers have been used. On the left right hand side is the CST 9 sleeper, and the Other side is CST11 sleeper. Not many changes are there, but you find that this is a keel which goes inside the ballast cushion. So, it gives furthermore a strengthening condition in terms of keeping it in position. Then the cotters are being used, tie bars are used, two-way keys are being used. So, there are different type of fastenings which needs to be used along with this particular sleeper. Similarly, here if we see that we have a rubber pad being provided at the bottom, then there is a clip being used, there is a cotter being used, there is a tie bar being used in the case of CST11 sleeper also. So, it means the number of fastenings are a bit higher. Now, what was the improvement? The improvement was there was a lesser corrosion, it was lesser liable to cracks at the rail seat because there are many things which have been used, and even a bearing plate has also been provided. So, the load is getting distributed and the rail base or the foot is not penetrating into it. It was easy to manufacture, it had high scrap value, and as well as it was free from the fire hazards. So, these were the improvements over the other sleepers, but still some issues were there. And what were those issues? The issues were related with respect to the gauge maintenance, and this gauge maintenance problem is because of the type of fastenings which have been used, as well as the design was such that it was not being able to retain the packings. So, there was a poor retentivity of the packing, and when you say packing, it means we are talking about the ballast. And there was a poor joint sleeper. So, if the rail is being provided and there is a joint, so a sleeper is going to be there at this joint. We have discussed this previously when we were talking about the sleeper spacings. So, if this has to work as a joint sleeper, then again there was an issue, because at joint sleeper there is going to be more vibrations, there are going to be the effect of the loads because of this overhang which is not being supported. So, there is a possibility of that getting tilting, and then if it happens, then this assembly is going to be a very difficult one to maintain. It was unsuitable for track circuiting, it was a mechanical maintenance problems. It was also not found good if we are going to the modern maintenance practices which have been adopted now using different equipments. So, there was an issue with respect to the maintenance side. It was susceptible to breakage. The rail seat wears were wearing out still early in this case, and there was a direct transfer of shocks and vibrations to the lower medium, that means the ballast, and that was creating a problem in terms of a loosening effect in the ballast. And it has also been observed that it can be used on the short welded rails or the simple rails with the fish plated joints, but if you are going to the long welded rails or continuously welded rails, then this is not suitable there. And specifically when you are talking to use these in the breathing lens. Again, we will be discussing about LWR and breathing lens in one of the forthcoming lectures. Now, let us come to the one which is in use now, which is a concrete sleeper. The design concept of this concrete sleeper is either it is a beam type or it is a two blocks which are connected by a tie bar. So, this is a beam type, whereas here there are twin blocks which have been connected using a tie bar here. So, this is the concept which has been considered in the design of concrete sleepers. And what are the design factors? Design factors are the different type of forces and the characteristics of the materials and the fastenings which are going to be used here. What it says, the forces which are acting on a sleeper, the forces can be the longitudinal forces in terms of vertical forces which are coming from the top, the forces can be the lateral forces, or a combination of that, and due to the eccentricity of the load there is also a possibility of certain moments getting created. Then another thing was the effect of geometrical forms. What type of shape has to be provided? If you look on this side or on this side of these two sleepers which have been shown, these are trapezoidal shapes. So, can we go for a trapezoidal shape, or can it be a square, or can it be a long rectangle in this form or a rectangle in this form? So, what type of shape is going to be good? We need to look at in terms of the stresses being induced, we need to be look in terms of the loads going to be transferred to the base and to the base to the ballast. We need to look at in terms of the strength parameters. And along with that, the economy is also an important aspect, and the weight is also to be looked at. Then characteristics of the fastenings, what type of fastenings which are going to be utilized while fixing the rail at the top of these, and the provision of failures, again derailment. If the derailment is there, what will happen to this material? This is a concrete. So, it is a mix of cement and aggregates. So, if the wheel comes at the top of these, whether these are going to be damaged, and if they are going to be damaged, whether they are reusable or not. So, the loading conditions for the broad gauge sleepers have been enumerated here. What are these? First one is the vertical load at the rail seat, which is being considered as 15 tons. Another one is the vertical load of 15 tons at rail seat, and the reaction of at center of the sleeper, which is taken as half of the load under the rail seat. So, half of the load under the rail seat, at the rail seat it is 15 tons. So, that is another critical condition which we consider for the design. Then the third one is the vertical load of 13 tons plus the lateral load of 7 tons. So, you are getting one load like this of 13 tons and another load like this which is of 7 tons. And if we are talking about the sleeper in this form on which the loads are coming in this way, so there is a possibility of this tries to overturn in this way, this is going here, and at the same time if it is we talk about the rail. So, if the rail is being provided top of this, then their stresses or moments are going to be created at the base. And another one is the bending moment, as I was saying that there will possibility of bending moment. So, it is 1.33 ton meter at the rail seat and 0.52 ton meters at the center of the sleeper. So, these are the 4 conditions which are being considered while designing these sleepers. Let us look at 2-3 types of sleepers here. Monoblock pre-stressed concrete sleeper is one. It is predominantly in use on the Indian railways. Trapezoidal section is there, provided with 1 in 20 Kent for 175 mm on either side of the center line of the rail. So, if it is a center line of the rail, then for 175 mm that Kent is going to be provided here. Initial pre-stressing of the steel is there and the values is 100 kg per centimeter square. The minimum strength for 28 days for the concrete which we usually consider it is 525 kg per centimeter square. And when we are fixing the rails here, then certain fastenings are going to be there. So, there are pandural clips which are used to fix the rails in position. There are elastic clips now available. This is also part of that, and these are being observed to be much better than the previous types of fastenings which were used to fix the rails with the sleepers. And it provides longitudinal and lateral stability which even is also required on the long welded rails or the continuously welded rails. So, it means it is a good aspect or good thing which can be utilized. Similarly, there can be another one which is a monoblock but post tension concrete sleeper. Again, many of the things remains the same, but here one value which is changing. In the previous one what we observed, it was 175 mm on either side, but now it is 325 mm from the center line of the sleeper. So, it is this one. So, if you go to 325 mm on this side and then go 325 mm on this side, then the Kent is going to be provided here as well as here. Initial pre-stressing force is 37 tons. The final pre-stressing force on the steel is 31 tons. The minimum strength at 28 days is 550 kg per centimeter square is same, and as well as the pandural clips are also used still in this particular case also. So, that is another type of system which is in use. Now, the concrete sleepers are also being used at different locations, but when we are using at different locations there are few things which needs to be taken care of. So, what is being written here is the first one are the rail joints. In the case of rail joints, the center to center spacing is being taken as 340 mm on the broad gauge. The rubber pads needs to be used. Along with that, the elastic clips are also required to be used. And similarly, in the case of curves, we have to maintain the levels, we have to maintain the gauge at that point. So, those type of fastenings are required. Then in case of heavy density routes, We are talking here the heavy density routes means there are 22 tons of axle loads which are going to be there on the rails, or it can be more than that. So, in this particular case, if we are going with a sleeper density of 1660 per kilometer, that is what we discussed, that if you are going to heavier loads, then this is the one value which can be there. Even the values can increase to 1880 per kilometer, but we are sticking to 1660 per kilometer in our cases. And using 60 kg 90 UTS rails, that means less than 90 UTS we should not go, 72 UTS is not allowed in this case. And the ballast cushion is going to be a bit heavy as compared to 200 and 250 which is normally being used in on the track. If we talk about the turnouts, then what it says is that the width at the top can be 240 mm, at the bottom it is 260 mm, the height is 210, the length ranges between 2750 and 4900 mm because it is a turnout. So, in the case of turnout at one particular location, you will require longer sleepers here. So, those longer sleepers will be there. But when you are talking here, then this sleeper is smaller, and when you talk at this point or at this point, then the sleeper is a smaller sleeper. So, that is the reason that that range is there in which it has to be created, and the 28-day strength here in this case is being taken as 600 kg per centimeter square as compared to the 525 which we have taken previously. Similarly, there can be the concrete sleepers at the level crossings and the guardrails. So, these are various things which are usually provided. There are some tests which are conducted on the sleepers. There are compressive strength test. Obviously, 28-day strength is required. 15-day compressive strength of concrete is also looked at. The 15 days of modulus of rupture of concrete is looked. Static bending strength of sleepers has to be examined. The moment of failure test is done for a rail seat bottom, because at that point only it is going to have problems and the cracks get initiated. Moment of resistance test for rail seat bottom and center top and the center bottom, as well as we have to go for electrical resistance measurement of these sleepers. What are the improvements about other sleepers? They being heavy, they provide more strength, they provide more stability to the track. They are suitable for LWR, which was a problem in the previous cases. This maintains gauges, alignment and cross levels. Again, this is a problem which has been observed in the previous cases. Track circuiting is possible because metal is not being used here. It eliminates corrosion, damages to pest and fire hazards. It has the highest life, and this is equivalent to the rail life. So, it means the renewal which is going of a track, the sleeper and the rails can be changed together. It has better mechanical maintenance, and there is a possibility of the use of local resources. And what are the issues faced? There are issues because they are heavy, handling and laying is difficult. But if it is a derailment, then heavy damages are going to be there because concrete cannot sustain those type of damages. There is no scrap value, the same problem as being faced in the wooden sleepers. They are not suitable for some meter packings, and the cost increases due to use of mechanical handling procedures. So, these are some of the issues which are there, but not many. There are prohibited locations where these concrete sleepers should not be used. If it is a troublesome formation, we found that the CST9 or the other sleepers could be used there. Rock cuttings without ballast cushion, if it is there, then there can be a problem. Unballasted lines in yards, there also we should not go for it. Curves of radius less than 500 meter. The location of excessive corrosions, and the unballasted arches or slab bridges or with fish plated tracks. So, these are some of the cases where we need to go for other sleepers, and that is where the concept of composite sleepers comes. So, we close this particular lecture now. So, we have discussed the type of sleepers, and the sleepers were wooden sleepers, steel trough sleepers, cast iron sleepers and concrete sleepers. We looked at their merits and demerits, and we also looked at some of the design criteria. So, we close now. Thank you. We will be meeting in the next lecture.